All right. So in the last class, we did a side quest, and I was showing you guys how to factorize a quadratic because you will need to use it to find the linear factors when dealing with polynomials. Trust me, it will need to. So last class, we looked at how to factorize simple trinomials. In other words, these are quadratics whose coefficient for x squared is 1. Right? So Avinash, I believe you were confident in these. Like you was okay with them, right?
Yes, I was okay with them.
Okay, let's move on to a harder one. Right? So what happens when it's not x squared? What if it's like 2x squared or 3x squared? We'll see. Right? Right. Right. So, Shina, do you want to give me an example of a quadratic whose coefficient for x squared is not 1 that could be factorized? Tell me, Shina, can you think of any? Shina, you're a little quiet on the hearing here. Um, okay, Serena, can you give me a quadratic that does not start off with x squared? Something that could possibly start off with 2x squared. That could be factorized. Or you want me to start off with a question?
Could you start off at one?
Okay, I'll start off with one. Right. So suppose we have something like, okay, let me think. Let me come up with one fast. Uh, okay, weird. I come up with one. So let's just say we had this quadratic and it was 2x squared plus 7x plus 3. Cool. And let's just say we wanted to factorize that. So Avinash, if we look at this particular question, what is the coefficient of x squared in this question?
Two.
Exactly, it's 2. So you could factorize this using the same method as we did last class, but it's going to be a bit harder to see. So let's try to do it using the familiar method, and then we'll do it using AC method, which is a bit more streamlined, and you'll get the answer. You'll get the answer without having to guess. So Avinash, let's try the first technique. So if I want to get 2x squared, what do you think I have to multiply to get back 2x squared? What two numbers?
X by X.
Nah, x by
Mm,
x would be x squared.
Sorry. I mean, um, 2 and X.
If I say 2 by x, I'll get 2x. I wouldn't get 2x squared. You actually have to combine them. So it
Oh,
would actually be 2x by x. What is 2x by x?
2X square.
Right. What
Right.
is the number? And the next thing we're going to do, right? What's the number that you could, what's two numbers you could multiply to give you 3, but yeah, just give me two numbers. I could give you three. What two numbers could give you three? If you multiply two numbers, what two numbers will give you three? What by
So
what?
would points count or not?
With what?
Like if you had like 1.2 and thing like, I mean 1.5 and thing like that, would that count or not?
Nah, nah.
Nah. 3 and 1?
Yeah, three and
Yeah,
one.
yeah, 3 and 1.
Now the problem with this method is you really have to be good with expanding quadratics in your head. So like just by looking at this, I could tell you that I would need to put the plus one over there and the plus three over there. But some people might put it in the wrong place. The reason I'm doing this is because I want to get positive 7 in the middle, right? And if I expand this, 2x by x is 2x squared, 2x by 3 is plus 6x, 1 by x is 1x, 1 by 3 is 3. So, Avinash, if you add 6x and 1x, would you get back the middle term?
Yes, sir.
Yeah. So, this is the correct answer. So, you see, we could use the previous method, but it's going to be a bit hard because you'll have to guesstimate quite a lot and then expand it to see if you're correct. Because, Avinash, if I had put the 3 here instead of the 1 and the 1 here instead of the 3, do you think it'd be correct?
Nah, because that wanna be more and wanna be less.
Yeah, it'd be wrong because watch. I would end up with 2x squared. 2x by 1, that'll be 2x. Then I'm going to end up with 3 by x, which is 3x. What's 2x plus 3x?
5x.
That is not 7x, so we can't do that. Right? So I'll show you all the AC method. So Shayna, can you
Yes,
tell
sir.
can you tell me the form of a quadratic?
Oh, x ax squared plus bx plus c.
Right. So in the AC method, what we are going to do is we're going to multiply the A term and the C term. So tell me, Shayna, what is the A term, what is the B term, and what's the C term? A is what?
A term is 2, b term is 7x, well 7, and c term is 3.
So if we want to find for AC, right? AC, what would AC be?
It will be 2 times 3.
2 times 3. Okay. All right. So AC. And the whole process here is, wait, let me just multiply it first. So AC, that would be 2 by 3, that would be 6. Okay. 6. So the whole point of this is, so Shayna, the whole point of this is you're going to multiply A by C, and you want to think of two numbers that when you multiply, you would get back 6, right? So we want to think of two numbers that we could multiply to get back 6, but it has to add up to the middle term. What's the middle term? Tell me, Shana, what's the middle term here? What's the middle term in this
Okay.
question?
7.
7, right? So the general concept is you're going to multiply A and C, right? Now, whatever number you get, the two numbers that you pick to multiply to give you back that product, it needs to add to give you the middle term. That's the concept. So, Shana, you understand that, right?
Oh, yes, sir.
So, what two numbers would multiply to give me 6, but add to give me 7?
6 and 1.
6, 7. All right. Great. So, what do you think I'm going to do in the next step? Tell me, Shana, do you know? This is the AC method. Do you use the AC method a lot? Shana? Okay, I'm not hearing Shana. Avinash, you there?
Yes, sir.
Okay, so Avinash, what I did so far, right? I, I figured out what A was, I figured out what B was, and I figured out what C was. To use this method, you're going to multiply A by C. If you multiply A by C, you're going to get 6, right?
Yes, sir.
And whatever numbers you pick to multiply to give you back 6, it must add to give you the middle number. So end 1 by 6 would give me back 6.
Yes, sir.
Oh, and when you add them, what would you get back?
7 when you add.
So this is what we're going to do. So you see this original expression? We're going to take that and we're going to split up that 7x into two things. So can't I write 7x as 1x plus 6x plus 3? Is that correct? Tell Marvinash, did I do anything that confused you?
No, sir, that's correct.
So you understand that x plus 6x is the same thing as plus 7x.
Yes, sir.
Great. The next thing we want to do is we want to factorize by grouping. So to do this, you want to split the equation. You want to split the expression in half, and you want to see if on either side there's a common factor. Right? So Avinash, if we look at 2x squared and x, is there anything in common between 2x squared and x?
Nah,
Yeah, sure. I see in something that they have in common.
but
It have something in common there.
positive.
No.
Nah.
What do both of them have in common? What do they have in the in like okay, like in 2x squared and x? You seen anything that look in the same?
Nah, so you're gonna break this one down for me.
Okay, it have x in it.
X? Does it?
Yeah, and okay. What you seeing here?
That's the X, yes, sir.
What you seeing here?
X.
Seen an x.
But
So
I
in
was
both
going
of
to
them,
think that like the 2x squared and x wasn't the same thing, and I don't know why.
no, they're not the same thing. X squared and x is not the same thing, but we're trying to pull out the greatest common factor, right? Greatest common factor. So a factor is a number that could go into another number without leaving a remainder. And x could go into this, and x could go into this.
Oh, yes, sir, yeah.
Yeah. So we're going to factor out x. If I pull out x from 2x squared, what would I write on the inside?
Uh, 2 plus x?
No, all right,
No,
2x.
2x? Okay.
Why? Why am I saying this? It's because if I pull out x from 2x squared, it means that I'm dividing 2x squared by x. One of the x's in the bottom would cancel off with one of the x's on top, and that would leave you with 2x. Similarly, if you multiply x by 2x, what are you going to get back? What is x?
2x squared.
2x squared, right? You need to get back the expression that you are factorizing, right? If I were to factor out x from x, that would be x over x. What's x over x?
0.
0.
Wait, x over x?
Yeah. Not 0. You lost me there.
Uh,
Question. What is 5 divided by 5?
So I think I lost myself here. Hold on.
How much time is 5 going to 5?
1.
Right, so the answer is 1.
Oh, 1.
1. All right, 1. So we're going to say 2x plus 1. And if you multiply x by 1, we're going to get back.
X.
Great.
Well, 1. Yeah,
1x.
1x.
Nice. Now we're going to look at the other half of the expression, which is the 6x plus 3. Are there any common factors between 6x and 3?
So because how much times 3 could go into x? 6 and 3. I
Yes.
mean, how much, yeah.
Yes. So we could factor out 3. If I factor out 3 from 6x, that's going to mean 6x divided by 3. 3 into 3 is 1, 3 into 6 is 2. So what am I going to write on the inside there? What am I going to write here? Avinash?
Uh, 2, 2x,
2x, yes. And if you multiply back 3 by 2x, what will you get back?
6x,
Right. And then we are going to say positive 3 divided by 3 to figure out what else to put on the inside. So you'll say 3 over 3. What's 3 over 3?
1.
So I'm going to put what over here?
I'm gonna put 1 there,
Like that?
and the bracket.
Now you need to say plus 1.
Oh, plus 1.
It's a positive number, so you put plus 1. Okay. Tell me if you understand that.
Yes, sir.
Nice. Next thing, are you seeing anything in common between this term and this term?
Inside the brackets.
The brackets are the same. So what does that mean? That means I could pull out 2x plus 1 from both of them. If I do that, I'm going to write 2x plus 1 on the outside, and on the inside, what would I write? So tell me, Avinash, if I pull out 2x plus 1 from both of them, what would I write here? See if you can figure that out.
X plus 3.
Yes, x plus 3. Great. Because if I pull out 2x plus 1, that means I'm dividing by 2x plus 1. That's going to leave me with x. Same thing over here. I'm dividing by 2x plus 1. It's going to leave me with 3. So altogether, just x plus 3. And that's the answer. 2x plus 1 by x plus 3. You have your answer there. You go with that?
Yep.
Right. Serena, do you understand this perfectly?
Yes, sir.
Okay, great. So I would like you all to copy this down, and then I'm going to give you all a question. Well, I want to do 2 questions in this, and then we're going to move on to factor theorem and remainder theorem. So as soon as you have everything that's on the screen, let me know so we can move on.
I have it, sir.
You have it? Serena, what about you?
I have it, sir.
Right? Shayna, what about you? Is Shayna with us?
I have it.
You have it? Okay. Let me give you all a question. So before I move on, I'm just going to recap the idea one more time. So Avinash, once your coefficient for x squared is more than 1, things become a little more complicated. So to avoid guessing, you could employ the AC method. So we're going to look at the coefficient of x squared, which is 2, the coefficient of x, which is 7, and this number is just 3. So A is 2, B is 7, C is 3. We are going to multiply A by C, hence the AC method, and we're going to get 6. Now, to get back 6, we are going to choose 1 and 6, because if you multiply 1 and 6, you're going to get back 6. Additionally, the numbers that you select must add up to what the B term was. So the B term was 7, so that's why I picked 1 and 6. 1 by 6 gives you 6, and 1 plus 6 gives you 7. So that's how we know it's the correct choice. Once we figured out what you would need to get back 6 and get back 7, you are going to use this to split the middle term. So Avinash, and I could split 7x into 1x plus 6x,
Yes, sir.
right? Then you're going to split the expression in half. If you look at 2x squared and you look at x, they have x in common. So we could pull out the x. If I pull out the x from 2x squared, that's just 2x. If I pull out x from x, that's just 1. And if you're confused, when you multiply it back out, you're supposed to get back 2x squared plus x, which you do, right? Now we're going to look at the other half. 6 and 3, they have 3 in common. That's the greatest common factor. So if I pull out 3 from that, it's going to be 2x for 6x. And if I pull out 3 from 3, it's just going to be 1. Then note that we have 2x plus 1 on the left side and the right side. Remember, we divided it. Well, we have it there here, and we have it there. So what we could do is we could pull out 2x plus 1 from both. And if I do that, I'm going to remain with x plus 3 on the inside. So question time. Right. Have fun, guys.
So you wanted to send us to you, like the answer, or like we just look it up in class?
No, this question is for you all to try now.
So I know I finished.
Yeah.
I got asking you want me to send you the
Oh,
working.
yeah. Send me, send me, send me. Hey, boy, shit, now you're bad. I had to give you one with negative numbers now. All right, Avinash, are you getting through?
Yes, sir.
All right. So, Serena, checking what you have here, right? Yep, that is correct, Serena. Yep, that's correct. That is correct, Shina. Nice. So I'm gonna put on the solution on the board. Avinash, did you finish?
Didn't finish, but I get up to like the second to last part.
All right, so let me work it out, right? So Avinash, Salma, what is A and what is C in this question?
A is six x squared.
No, that's not A. A is not
Sorry,
x squared. A
six
is the coefficient of x squared. So what's A?
six. My
right?
bad.
A is 6 and what's C?
C is 3.
So what are you going to do with those two numbers,
Can I multiply them?
right? Where's 6 by 3,
18.
right? And just keep in mind, whatever numbers you choose, it must add up to what?
11.
Perfect. What two numbers you picked on? I mean, you decided to pick.
2 and 9.
All right, I like what you're thinking there. 2 and 9. Because if you multiply 2 and 9, you're gonna get 18. If you add them, you're gonna get 11. Right? So what should I instead of writing 11x, what could I write?
You write 2x plus 9x.
Mm-hmm.
Then you put in the rest of the sum. That will be
All right. Now we're gonna split this in half, and we're going to look at this side first. Is there anything in common between 6x squared and 2x?
the x and the 2.
Perfect. X and the 2. So that means I'm going to pull out 2x. If I pull out 2x from 6x squared, what would I get?
4x.
Nah, if you multiply that back out, 2 by 4 is
Oh,
8. That'll be 8x squared. Nah. So if you're having trouble with it, do the long way. So that would be 6x squared divided by 2x. 2 into 2 is 1, 2 into 6 is
okay.
Naviash. 2 into 6 is 3, right? One of the x's here will cancel off with one of the x's on top. So I'll end up with what?
That will be 3x.
And an easier way to do it, check this. So whatever you put here, when you multiply it by 2x, you should get back 6x squared. So what by 2 would give you back 6?
3.
And what by x would give you back x squared?
Um, x.
Right? So 3x. Nice. And if I factor out 2x from 2x, that literally means 2x over 2x, which is just what?
1.
Right. So let's look at the other half now. So 9x plus 3. What do they have in common?
3.
All right, so if I factor out 3, what am I going to write here?
3.
Just 3.
Well,
Remember,
yeah,
I want to get back 9x. So I have to put
yeah.
3x. What next?
And that's plus 1.
Yes. I'm not sure if you noticed by now, but check this. If you do it correctly, this and this supposed to be equal.
I guess I was noticed that.
Yeah. If they're not equal, then you can't do factorization by grouping. Right. All right. So we notice that 3x plus 1 is common in both of them. So I'm going to pull out that. And what would I write on the inside?
2x plus 3.
Yes. All right. One last question. Ladies, you all are going to love this question because they're going to have negative numbers in this question. Shane, are you excited?
Yes.
I like the attitude. All right. So, minus 6. All right. Good luck, guys. So, ladies, since all is so brilliant, I mean in a good way, not in a bad way, I'm going to give you all 2 minutes to finish the question. Do you all think you could finish this in 2 minutes?
Yes, sir.
Serena, 2 minutes
Yes, sir.
or 1 minute?
Nah, 2.
Okay, okay. Go. Fast. Avinash, don't worry. You'll get it. You'll get it. I know you'll get it. Take your time. I'm not rushing here. I rushing Gales though. Yeah. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ladies, pens and pencils up.
Last time it's already.
Way! Absolute legend. Legend. Serena, what about you?
I just sent it.
Way! All the ladies dread boy. Okay. Yeah, and both of you all are correct. Great job. Great job. Way boy. Like these questions not stressing all out at all. All right. Avinash, you get answer?
Nah.
No? Okay, well let me do it together, right? So first things first, what is A and what is C?
-6 and 3.
All right, so we're gonna multiply -6 by 3. What would you get?
8, -18.
Right. So we need to pick two numbers very carefully, right? So the two numbers that we pick, it must give you back -18 when you multiply, and when you add it, it needs to give you back 7. So does any numbers come to mind?
Um, nah, sir.
All right. I want you
I
to
was
think
thinking
about it like this. Okay, so to get a negative number, you'd have to multiply a what by a what to get a negative number.
negative or positive.
Right. So one number is going to be positive and the other number is going to be negative, right? Yeah.
Yes, sir. Yes, sir.
Now, how could I get 18? Think of two numbers that would give you 18 if you multiply them.
Well, I know the 6 and 3, but I don't think that one will work here.
Nah, 6 and 3. Think about it. If you add 6 and 3 or you minus it, you wouldn't get 7.
They won't get it. That was that I think about, sir.
Think of two other numbers that could multiply to give you 18.
9 and 2?
Right, 9 and 2. That'll give you your answer. What would you have to do with 9 and 2 to get 7?
You can put positive 9 and the 2 will be negative.
Exactly. Pick up yourself. So if I add +9 and -2, I'll get 7, right? Because this will essentially be 9 minus 2, which is 7. Yeah. So what I'm going to do is I'm going to write, instead of writing 7x, what do you think I'm going to write?
We're gonna write the positive 9 plus the bracket -2 bracket.
right? So here it is. For simplicity's sakes, we could just write 9x minus 2x.
Okay.
Yeah. Right? Right. So for the sake of simplicity, this is much easier to look at. Because then 9x minus 2x is 7x.
Yes, sir.
And 9 minus 2 is 7. So that makes sense. We're gonna split it in half, split in the middle, right? I don't know if I know that song, right? But we split it in the middle, and we're looking at minus 6x squared and 9x. Is there anything in common between 6 minus 6x squared and 9x?
The x's
The x's for sure. And is there any number that could go into both 6 and 9?
3.
Right. So I'm going to write 3x over there. What would I need to multiply? So I have two routes you could do this. You could say minus 6x squared over 3x. You could do it like that. Or you could ask yourself, what would I need to multiply by this to get back this? So let me start. Which one you prefer, the division or the trying to figure out what to multiply? We need
Inside
to,
division. Inside division might be easier.
okay, well, let me stick with that then. So minus 6x squared all over 3. So we have positive 3 divided by negative 6. So first of all, it's a negative divided by a positive,
Or negative.
right? So we know that the final answer will be a negative, so I'm going to put negative here regardless. Then 3 into 3 is 1, 3 into 6 is 2. So then I know I need to put a 2 over there, right? And or I forget the x. And then one
The
of
x
the x's here would cancel off with 1 over here, so that would just be negative 2 what?
-2x.
Right. Okay, and now we need to look at positive 9x. So that would just be 9x over 3x. What's 9x over 3x? X's would cancel off. So what would happen?
There's the 3.
You had to tell me the sign. You had to tell me the sign.
Positive 3.
Right, let's move on to the other half. In the other half, we have minus 2x plus 3. So you have to be very careful with this one. Very, very careful. Extremely careful, dare I say. So notice that we have minus 2x plus 3 here, right? Yeah?
Yes, sir.
Okay. So I hope I don't lose it here. I'm going to write plus. I actually don't need to factor out. Well, I suppose if you wanted to, I guess you could factor out plus 1. I guess we could do that. So Avinash, look what I'm gonna do, right? I'm going to factor out 1. And I'm just going to write back minus 2x plus 3 here. It looks complicated, but stay with me. If anything you multiply by 1 is what? Like if I say 5 by 1, what's 5 by 1?
5.
What is 1 by a million?
A million.
So what would 1 by minus 2x plus 3 be?
-2x plus 3.
Exactly. So I did not change anything. I didn't do anything crazy. We still on Earth, right? Earth is still round. Earth is not flat. We didn't do any madness. So since I did that, I could now pull out what from here and here.
Yeah, -2x plus 3.
Right, I could pull out minus 2x plus 3, and I'm going to write what here and what here.
3x plus 1.
Yes.
So if you don't, actually, yeah, never mind. You would have to put it there.
You okay?
Yeah, no, I was not gonna ask about the one. I was like, wait, nah. Then you, yeah, yourself, wait.
Yeah, to see it, you had to put it 1, right?
Yeah.
Okay. So ladies, you all ready to start factor theorem and remainder theorem?
Yes, sir.
Okay. Before we do that, let's just recap everything we did up to this point very fast. Right? So recap. A lot of people often like they don't know when to use long division and they don't know when to use factor and remainder theorem. So far in class, we looked at what? Polynomial long division, yes? And we
Yes,
looked
sir.
right. So Sheena, we often use polynomial long division to find the what for an expression. To find the what's. Starts with F.
Factor.
Right. So we only use polynomial long division when we want to find all factors. I spelled division wrong. That's crazy, bro. That's real crazy. Right. Yeah. So this is the only time when you should use polynomial long division. Generally speaking, you will not do polynomial long division to see if something is a factor. You will not. And let me explain why. Shina, you think it makes sense to do all of this just to see if this is a factor of this?
No, sir.
No. That don't. The only reason why we're doing polynomial long division is to figure out what this is. Right? Do you all remember what we call that? What do you call the expression that's on top of the divide? The long division sign.
Equivalent.
Say that again?
Equivalent.
The dividend?
No, sir. Equivalent.
The quotient, right? The quotient. And this would be the devise. What would that be? Divisor, right? Divisor?
Yes.
Okay. And what would this be? This.
So equation.
No, the dividend.
Oh, you want to like that? Right. Sorry.
Yeah, that's the
Following.
dividend, right? So guys, we only use polynomial long division when we want to find all the factors. There's no other reason to use it, right? So if you see a question asking you to prove if something is a factor, or they're asking you to find the remainder, you're not going to use long division. The only time you're going to use long division is when they ask you for all the factors. That's the only reason why you should use it, right? I'll put that in red. Only use long division Okay, great. So that brings me now onto factor and remainder theorem. Yay. Right? Factor. Right. So the factor and remainder theorem is essentially the same concept. It's the exact same concept. Just remind me, guys, if something is a factor, what is its remainder? If something is a factor, what is its remainder?
0.
0.
Right. Remainder. If something does have a remainder, then the remainder will not be equal to 0. It will be equal to some non-zero value, right? Great. Glad that is out of the way. And let me show you how this is work. So let's find a previous question. I'm gonna make sure I didn't delete. Did it delete? No, it's still there. Good. Good. Right, so I want you all to observe what that question is asking versus this question I'm going to write here. Right? Right, so okay, so Avinash, I want you to compare these two cases, like this question and this question. What are they asking of us in this question, Avinash?
Just to find a factor of f and x.
No, they're asking you if x minus 1 is a factor. I'm not sure if that's what you meant. That's what you meant?
That's what I meant, my bad.
Okay, so they want us to prove if x minus 1 is a factor. Now, Avinash, hence we could divide and see if we get a remainder of 0, and that would prove if it's a factor.
Yes, sir.
Yeah, we know that, right? So you could say x minus 1 is yada, 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 you know, and you're going to put 0. And if it's a factor, if that's the case. But that's a lot of working to do, right? That's a lot of working, yeah?
Yes, sir.
That's a lot of working. Right, so observe what they're asking here. They want us to prove if it's a factor. Over here now, they're asking you to find all the linear factors, given that x minus 1 is a factor. So two very different questions. This question, since they're asking you to find for factors, long division. Over here, remainder factor theorem. Right, so let's begin the question. Right, so Shayna, the very first thing we're going to do is we are going to equate the factor to 0. So we're going to say x minus 1 is equal to 0. And tell Machina, if x minus 1 is equal to 0, what would x be equal to?
1.
What are we going to do with that number? If x is equal to 1, what am I going to do with that to see if it's a factor of f of x?
You can plug it back into the question.
Right? So you could say by remainder you would say f of 1, and that would be equal to 2 by 1 cube plus 3 by 1 squared minus 9 by 1 plus 4. Now, tell me something, right, Avinash? If something is a factor, what is the remainder supposed to be?
0.
Right. Anytime you take you take a divisor, you put it equal to 0, you find for x and you plug it in, it will give you the remainder. So that's what this concept says. So Avinash, by me doing this, by me taking 1 and putting it into the function, when I compute that, I'm actually getting the remainder. That's what I'm doing. So let's work this out, Avinash. What's 1 cube?
1 cube. 1.
1. And where's 2 by 1?
2.
Right? So 2 by 1 cube is 2. Where's 1 squared?
1.
3 by 1 is?
3.
Okay, where's minus 9 by 1?
Minus 9.
What is, oh, that's just plus 4. Right, what is 2 plus 3?
5.
Right, so we have 5 minus 9 plus 4. What to do next? What's 5 minus 9?
5 minus 9 is -4.
right? What is minus 4 plus 4?
0.
Right. So since we got a remainder of 0, is x minus 1 a factor?
Yes, sir.
Right. And so you would say since f of 1 is equal to 0, x minus 1 so what this boils down to, right, is the remainder right. So Avinash, all the factor and remainder theorem says, I shouldn't even say and, I should just say like slash, because it's the same concept. It's literally the same concept. It's literally the same concept, right? So Avinash, based on what you're seeing so far, does it look hard or does it look simple?
Looks simple enough.
All right, so let's just run through these steps, right? Let's see what is going on.
I kind of looking hard, my boy.
No, this is very easy, Tavon. Avinash, tell Tavon, and it's looking real easy.
Yes, sir. I can really see.
Yeah, I know, right?
You,
So
you know, I only say it looking hard, right?
if you actually thought this was hard, I would have cried for you, know. I would have cried for you. I would have cried for you.
I say it looking hard. I mean it hard.
Okay, that's good. All right. So Avinash, we wanted to test if x minus 1 was a factor of f of x. Obviously, we are not going to do long division. What we are going to do instead is to equate it to 0 and find for x. So x is equal to 1. If x is equal to 1, using the remainder factor theorem, all I'm going to do is I'm just going to take x is equal to 1 and substitute it into f of x. So anywhere I see x, I'm going to replace it with 1. From there, I'm just going to work this out, and if I get 0, it means that the remainder is 0. If the remainder is 0, it's a factor. Simple.
Yep.
So Avinash, what you're finding here is actually the remainder. Right? That's why I say factor slash remainder theorem is the same thing. So Avinash, if you get 0, it's a factor. Factor theorem. If you get a number that's not 0, remainder theorem. Simple.
Yes, sir.
Okay, so I want you all to copy this example down, and then I'm going to give you all a question. Serena, is it straightforward?
Yes, sir.
Okay, nice. Tivon, how preparation for maths exam coming along?
I ain't worrying about maths exam. I worrying about circuits. Cause I know Oxyman is so like if we can get like some formula sheets for the midterm because the formula sheets looking kind of hard. I might say nah. So I
Manu?
forgot. Yeah,
Manu,
boy.
formula sheet? Oh, he
I
would.
go learn all the formulas now for the exam.
It really how much formulas to remember?
No, I had 3 cases and I had no the formulas them for each case. Cause I had underdamped. Well, he say he ain't doing underdamped. You get overdamped, critically damped. And yeah, I remember like yeah, I know how to figure out if he underdamped and then which formulas them to use for them cases. So I
Okay.
forgot on them.
Oh, so you guys are transients.
Yeah.
Okay. Good luck, my guy. Good luck.
Yeah, but I real pressure.
Although I would have been wishing to have that worries instead of programming right now. I would wishing had that worries as circuits. I would pick circuits
Yeah,
over programming.
yeah, this man wishing for different worries. Anybody does wish for is, boy?
I could handle these circuits worries. You see that thing? Let me show you what I had to learn for programming. And this is like part of it, eh? This is part of it. This is not the whole thing. I'm gonna send you it. All right, so ladies and gents, as soon as you all copy this down, tell me, I'm going to give you all a question.
So I'm done.
You finish?
Yes, sir.
All right. Serena, you finish?
Yes, sir.
All right. Avinash, what about you?
Now finish.
I'll finish. Okay, let me give you all a question.
Bro, I'm not telling no lie. Well, you know, send me it. I feel you could learn this if you just had the time to do it.
Yeah. I'm
It's just,
watching this lecture on YouTube, and one is six videos. One of the videos is 5 hours, the other video is 2 hours, the other video is 1 hour. Yeah.
yeah, but like if you had the time for it, I feel it's because you don't have enough time. That's why you're struggling. But if you have the time for sit down and learn this, bread,
I will grind it, I will grind it.
yeah,
After
boy.
after class, if you're down, we could do a Zoom call on because I real stressing out over this thing, boy.
I really don't, cause I plan for the whole weekend just grinding, cause I have maths and circuits the same day as Monday,
Hmm.
same day. I ain't worried about maths. I worry about circuits now.
Ah,
Maths are full on some formulas too, but I'm ain't too bad. I see man go through some steps, I understand them. I say, all right. And man tell you all the formulas and shucks me.
yeah, I find like honestly, I would have preferred the lectures was online. I really would have preferred that.
Yeah,
Okay,
because in class, the man was flying.
wait, let me ask my students. Guys, do you all prefer online classes or like physical classes? What do you all prefer?
It depends.
It depends. It depends on
Depends on the subject.
depends on the subject. Okay, like maths. Do you all prefer maths online or like physical?
I'm not sure. I've done both. Um, I don't know.
Okay, what about physics? Honestly, I,
Physical.
I feel like physics better physically, you know? I would say so. Because when we come to things like Fleming's left hand rule, Fleming's right hand rule, right? You kind of need to see it in real life. Yeah. All right. So, guys, try this question. I'm giving you all, ladies, tell me how much time to give. 1 minute. I think y'all could do it in 1 minute. Shana,
Awesome.
okay, 1 minute. Right.
Mhm.
All right, start. Action. All right, so time is up, ladies. Did y'all get through? Serena, Shana, did y'all get through?
No.
Yes, sir.
Serena, was that a no?
Yeah, that was a no. I didn't finish yet.
Okay, okay. How much time you think you need again?
About a minute.
A minute?
Yeah.
Okay. You see, you having trouble because you don't have a Casio. And I still didn't get a chance to get the Casio for you. I didn't forget. But if you have a Casio, this real easy. Like so easy. Avinash, she getting through?
So far, figuring out what to do.
Alright. Avinash, I'm gonna show you how to use that calculator you get.
Yes, I could help out yeah, a little bit, yeah.
Okay. So first things first, right, Avinash? If I want to see if it's a factor, I'm going to use remainder factor theorem, which says I'm going to take the divisor. In this case, the divisor is 2x plus 1. I'm going to equate it to 0, and I'm going to solve for x. Tell me, Avinash, what would x be equal to in this case?
X will just, wait, terminate the X from the thing.
So you have to find for x here. You have to make x the subject of the formula.
Okay, I think I understand here.
So if you want to find for x, you need to leave x on the left-hand side, or you need to keep it on one side and move everything across. So is x the only thing on this side?
Nah,
Now, what we have on that side as well.
we have a 2 and a plus 1.
Forget about the 2 for now. The 2 is
Just the
is with
plus
the
1.
x. The 2
Okay,
is
just the plus 1.
right, the plus 1. So what can we do with the plus 1?
Move it across.
Right? Now, 0 means there's nothing on the right-hand side. There's nothing on the right-hand side. So when you move across a minus 1, you don't need to put back the 0. You could just say 2x is equal to minus 1. Because we moved across plus 1 to the right-hand side, which had nothing in it, but now it has minus 1 there. You understand?
Yes, sir.
And what next? How do we find for x?
So then you had, this is again, wait.
So I have 2 multiplied by x. What I have to do on both sides so that the 2 would cancel off.
Oh, divide by 2.
Right. Right? Because the opposite of multiply by 2 is divide by 2. So if I do that, it's going to be 2x over 2. Yeah, you see the 2 and the 2 going to cancel off there.
Yes,
Right?
sir.
So x is just equal to
X just equal to, minus 1 over 2.
right. Great. And now notice they didn't give us a function. They didn't call it f of x. So we could now say let f of x be equal to 10x squared plus 11x plus 3. And we are allowed to do this because this is a function. It is a function. And in the next line, we are going to actually substitute what x is. So we found x to be minus a half. So that's what we're going to plug in. So we're going to put 10 open bracket minus a half squared, then plus 11 by minus a half, right? Plus 3. Right, so Avinash, you understand everything I did so far?
Yes, I understand that one.
Like 100,
95.
95.
Yeah.
Okay, what confusing here?
Something now the part that confused me was like how you always be sure that you has had wait, like how you always be sure that you move the other number.
What do you mean, yeah, a number? Like this part over here confuse you?
Yeah.
Okay, so we want only x. I guess let me show you like the full working, right? If you have 2x plus 1 is equal to 0, we're trying to find for x. So in other words, x should be the only thing that's on the left-hand side. We don't want anything but x on the left-hand side. Yeah?
Yeah.
So the full working would be this. First, we're going to minus 1 on both sides. Why are we doing that? I'm doing that so we could get rid of the plus 1 on the left-hand side. If I minus 1 on both sides, what's going to happen to the plus 1?
It just cancel out.
Yeah, we'll cancel out, right? So then we end up with 2x is equal to negative 1, right? Then I want, so here what, right, Avinash? Understand that,
Now understand that part, sir.
so we're very close to just x, right? And to finish off, I would need to divide by 2. Why? Over here I have 2x. I want to find for 1x. So I would just divide, right? So if I divide both sides by 2, the 2 and the 2 would cancel off, and so that would leave me with x is equal to negative a half. We could look at another question. What if I had 7x minus 3 is equal to 5? Same process. See this minus 3? It does not belong there. To get rid of the minus 3, I would need to add 3 on both sides, because then plus 3 is the opposite of minus 3.
Yes, sir.
So where's negative 3 plus 3?
0.
0. So on the left-hand side, we're just left with 7x, and on the right-hand side is just 5 plus 3. So then we end up with 7x is equal to 8. Now, again, I want to find for 1x, but then I have 7x. So I need to divide both sides by 7 to find for 1x, because 7 into 7 is 1. So 1x would be equal to 8 over 7. So typically, you're always going to move across whatever term you're adding or subtracting. So in this case, I move across plus 1. That's into minus 1, right? In this case, I have minus 3. So I'll move it across to get plus 3. But Avinash, what you're actually doing is you're actually adding 3 on both sides so that the minus 3 would cancel off. But the shortcut for that is you just move it across. And if you move it across, it goes into plus 3.
Oh, yeah. Okay, I think I understand now, sir.
You're sure not confusing you?
Nah, I'm sure. You ain't confused me.
Okay, so you understand that, okay, so if I have 7x minus 3 is equal to 5, me moving across the minus 3, it'll be 5 plus 3. This is just a shortcut version of adding 3 to both sides. So instead of actually writing plus 3, you could just move across minus 3 and it could turn to plus 3. Right? Cool. So, you okay?
Yep.
Okay, now we're gonna show you how to plug that into your calculator. Let's do that now. Right, so
So you
Avinash,
know, the other day I asked my teacher in school how you do this, and he said he ain't even know how to operate this calculator.
he's a sharp man.
Yeah, he like sharp.
Exactly. He is so sharp. All right, so the calculator you have is essentially a Casio, like what I have here. So
Yes.
you are going to plug in the right hand side. So you're gonna put 10. So you'll tell me if you're with me, right? Put 10,
Yeah.
press the open bracket button, which is this button over here. Wait, give me a second. Annotate. All right. All right. Okay, you see in the annotation, you
Yes,
see
sir.
a little red dot.
Yeah, I seen it.
Okay, that's so you want to point. So you see this open bracket here, you press it, and you should see 10 open bracket.
Yeah.
Then you're going to press the fraction button. You see a fraction button like this.
Yes, sir.
Press, but before you do that, press minus. So press minus. All right, so 10 minus. Then you're gonna press the fraction button, right? And then you're gonna put 1.
Yes,
Do it now.
sir. Yeah.
Then you're gonna press the right arrow to move down to the denominator. And in the denominator, you're gonna put 2. Then
Yep.
you're gonna press the right arrow to come out of the fraction. Then you're going to close the bracket. Then to square it, you're going to press the x squared button. You with me?
Yes, sir. I
You
did.
should. And then you're going to press plus 11. Then you're going to open up a bracket. You're going to press minus. Then you're going to press the fraction button. Then you're gonna press
Yes,
one. Then you're
yeah,
gonna
mag.
same thing. Press the right arrow, move to the denominator. Then you're going to press the right arrow to come out. Close the bracket. Then you're gonna press +3. Press equal for man. Tell me what you get.
0.
Right. Yeah.
Okay.
Right. So 0. So my question is, since you need to write the statement, right? Since f of minus a half was equal to 0, you would say 2x plus 1 is a factor of f of x. Nice. So that's the working you're supposed to have. You okay with that?
Yes, sir. Thanks, sir.
No problem. All right. So ladies, are you ready to step things up a notch? Tell Machine, are you ready to like step things up?
Yes, sir.
Okay, this stuff way too easy. So if hmm, if x minus e is a factor of gotta be careful to come up with a question very fast. Uh, all right, so if x minus a is a factor of x squared minus 4x plus 3, find for e. So I think I might have to do this question with you all. Right. So Shayna, what are they telling us in this particular question?
That x minus e is a factor
So
of
if
x squared minus 4x plus 3.
so if it's a factor, what could we use?
Sorry.
So if it's a factor, what could we use to go forward?
F of x?
Wait, you said f of x?
Mm-hmm. What about equal to 0? Nothing. So I feel like I don't know exactly what you're talking
Okay, let me run through the question together. I think you know what to do, right? So the very first thing I'm going to say is I'm going to say x minus a is equal to 0. And I'm going to solve for x. So if that's the case, x would be equal to what? Tell me, Shana, what x be? X would be equal to. The next thing I'm going to do is I'm going to say, let f of x be equal to the expression that we were given. X squared minus 4x plus 3. Nice. And now, Shana, if this is the case, look at what we are allowed to do. Since x minus a is a factor of f of x, then f of a should be equal to what?
0.
Right. So my next line, I'm going to write f of a, and f of a would be equal to, you tell me. Oh, you wouldn't be able to solve this, you know. You wouldn't be able to solve this, and I realize that. Yeah. Actually, no, you could solve it. Let me continue. Let me continue. You would be able to solve it. All right. Yeah. So Shayna, tell me.
Usually fe equals x squared.
Nah.
A squared minus 4a plus 3.
Okay. And okay, never mind. Let me just keep going and see if we can solve it, right? And Shina, what am I gonna do now? What is f of a? What do we know f
0
to be? F of a is 0, right? So I could say 0.
equal to 0.
All right. This is actually a very nice question because we just did factorization. I love this question. This is a peak question, right? I just confused you because you only see the screen. Wait.
So yeah, my screen frozen.
You all see the screen now?
So mine's still frozen.
I'm moving the screen. Are you seeing the screen being moved?
I seen it, sir.
Okay. Shina, you seen it?
No, so I think I'll leave and jump back this time.
Okay. Right? Serena, do you think you could see where we're going with this?
I'm not sure.
Okay. So Serena, the whole point of this is to find for what? What do we want to find for? If you're talking on here, try speaking a little louder. What do we want to find for in the question?
E?
We want to find for A. So right now, we have an equation, right? We have an equation there. And the equation is in terms of what? What is the equation in terms of?
E?
Yeah, it's in terms of A. And this expression here, starts with Q. What is it?
A quadratic?
It's a quadratic, right? It's a quadratic. So do you know how to solve a quadratic? Using factorization.
I'm supposed to? Yeah.
Okay, nice. So the next step would be to factorize this. Now, is this a simple trinomial?
Yes.
Yeah, so it should be easy to factorize. What would I have to multiply to get back a squared?
A by A.
Right? And what would I have to multiply to get back plus 3?
1, 1 on 3?
You said 1 and 3?
Yeah.
But if I add 1 and 3, am I getting back negative 4? So think carefully. So 1 by 3 is 3, but there's another case.
It would be -1 and -3.
Correct. Right? So if this is the case, I could say that a minus 1 is equal to 0, and I could say that a minus 3 is equal to,
0.
so a would be equal to,
+1.
and a would be equal to.
3.
All right, so these are my two solutions. Those are my answers. Yeah. And in case you're confused, check this, right? So Serena, if a is 1, wouldn't my factor be x minus 1?
Yes.
If x is equal to 1, whenever I plug it into this, what am I supposed to get?
0.
I'm supposed to get 0. Let's try it. 1 squared minus 4 by 1 plus 3. 1 squared is 1, minus 4 by 1 is minus 4 plus 3. What is 1 minus 4?
-3.
What is minus 3 plus 3?
0.
So that worked out. Great. What if we now say um x minus 3? X minus 3 would be equal to x is equal to 3. So that would be 3 squared minus 4 by 3 plus 3. What is 3 squared?
9.
Minus 4 by 3 is?
-12.
9 minus 12 is?
-3.
Negative 3 plus 3 is?
0.
So our answer is correct.
Yes.
You notice all we essentially did was we just basically factorize.
Yeah.
Yeah, we just factorize what? We literally just factorize it. Yeah. So that was like a nice question, but also a dumb question at the same time because it is nothing new. So you all could copy this down and I'll look for a past paper question. Right? Remainder and factor theorem is very simple. It only gets complicated when you start throwing in simultaneous equations. Serena, how are you with simultaneous equations?
I'm good now.
Say that again?
I'm good with it.
Okay, nice. Nice knowing that. Shayna, are you okay with simultaneous equations?
Yes, yes, sir. And we
Avinash.
did this in school.
Okay, okay, cool. Avinash, did you do simultaneous equations before?
Nah, sir.
Okay, so you might be a little lost. That's okay. I will go it over. Right? So you all could take a screenshot of this. It wasn't a very eventful question. I'm gonna find an actually good question. Actually find a good question, right? So going into my book, right? Okay, here's a nice question. So I'll do a couple questions with you guys, and then eventually I will let you all do it for yourself. All right, so Avinash, I'd like you to question read this question from 2012. Ladies, you all could do it and see if you get the answer, right? Right. So Avinash, I would like you to read the question.
If x plus 2 is a factor of fx equals 2 2x cubed minus 3x squared minus 4x, add a, find the value of a.
So be honest with me, Avinash. And you think you have ideas or what to do? Like be real honest with me. Yeah or no?
Nah,
Nah.
nay.
Okay. What did they say about x plus 2?
If it was a factor.
So they're saying it is a factor, right? So that's what they're saying. They're saying that x plus 2 is a factor.
Oh, okay, it's
Okay, so if x plus 2 is a factor, then what do we know about the remainder?
it should be 0.
Right. So what would I have to put into this to get 0? What would I have to plug into the function? X is equal to what?
2 plus
No,
2.
nah,
No? Ah, 1.
no.
No?
I want you to remember how it is go, right? You always, to work it out, you need to equate the divisor to 0
Oh,
and then solve for x. That's how the factor remainder theorems go. So,
okay. Okay.
as the very first step. So, in other
Um,
words, it would say x plus 2 is equal to 0, and then you would find for x. What would x be equal to?
1.
No.
No? Oh, x equals 0. All right. I
You
say
want?
one second, I was thinking about, um, it's like, when you see 1x is counted as a 1.
Nah, confused.
Okay. Anyway, I can say that. Okay. Sorry, I don't know. Explain it.
All right, x plus 2 is equal to 0. What would I have to do to make x the subjects?
You move across these two,
Right, if I move across plus 2, we go to,
-2,
so x is equal to,
-2. So
yes.
it'll be
Remember, 0 just means nothing. So there's nothing on this side. You just move across -2. So I could just write x is equal to -2. Tell me if you're confused.
nah.
All right. So this is always, okay, so anytime you want to use factor remainder theorem, this is your first step. You need to let the divisor be equal to 0. Right? I'm going to put it equal to 0, and I'm going to find a value for x. So x is equal to -2. Now, Avinash, what are they saying about x plus 2?
It's a factor.
So if it's a factor, what does that say about the remainder?
It had to be 0.
Right? So remainder. All right. So in other words, f of what would be equal to 0?
-2.
Right. Remember how this is work. If you want to figure out the remainder, this is the general procedure, right? This is the general procedure of factor remainder theorem, right? Factor. Right, so this is the general procedure. Whatever you get, so let me just say you have something like x plus a, all right? No, I feel like I would need to use that example. Okay, Avinash, essentially what you're doing is you are taking the divisor, you're putting it equal to 0, and you find what x is equal to. Once you find what x is equal to, you're going to plug that into f of x. And this will tell you, so we could probably say x is equal to p, right? So Avinash,
sir.
what I'm saying is once you find for x, actually I could just say x minus p here. I just say x minus p. So once you find for x, right? Once you have x, you're gonna plug that into the function. And that will give you the remainder. That's essentially the whole of factor remainder theorem. So Avinash, they are going to give you a divisor or a possible factor, same difference. Right? So they might tell you x minus 1 is equal to 0, x minus 4 is equal to 0, something like that. You have to find what x is equal to. Then they're going to put that into the function, and that will give you the remainder. You saw it for the previous questions, such as this one, right? So in this question, we put x minus 1 equal to 0, you find for x, and then you put x back into f of x, and you got 0. That gave you the remainder. So you understand the general procedure?
Yes, sir.
So you're finding what x is, you're plugging it in, and that will give you the remainder. If it's a factor, the remainder is
0.
right. So they're saying that x plus 2 is a factor of f of x. So that means when x is equal to -2, f of -2 has to be equal to
0.
right. So when I put -2 into this, it's supposed to be equal to
0.
right. It's supposed to be equal to 0. Let's test that theory. So I'm going to write f of -2. So anyway I see x, what am I going to write?
-2.
All right, so I'm going to write 2 open bracket -2 cube, then -3 open bracket -2 squared, then -4 open bracket -2 plus a. You following so far?
Yes, sir.
Okay. So this is the one thing you can't put into your calculator. So what you're going to do is you're going to plug this part into your calculator and compute a number for that. So we are going to put, right, so we are going to put 2 minus 2 cube minus 3, open bracket, minus 2 squared, minus 4, open bracket, minus 2, close bracket, and you should get minus 20.
Yes, sir.
Right. And just remind me, Avinash, what is f of minus 2 equal to? What do we know it's supposed to be equal to?
0.
Right, because x plus 2 is our factor. So we could write 0. And 0 would be equal to minus 20 plus a. Are you lost?
Nah.
Right, so what do you think we need to find for now? What's the only unknown there?
The A.
Right. So if you want to find for something, you need that variable to be the only thing on one side. Now, there are multiple ways you could do this. What way are you thinking to do this?
Basically moving everything behind the A.
Moving everything behind the A.
And putting like moving the A up in front. Like by the equal sign.
So call out what you have in mind. Call out what you have in mind.
I'm like basically rearranging the whole thing, sir.
So tell me what I would
Like
end up.
I explained.
Tell me what I would end up with here then.
It's like A equal minus 20.
Nah.
No? Okay.
All right.
He close though. He close though.
Yeah, he close, but not quite. So watch this, right, Avinash?
Yes, sir.
Now, I'm gonna show you two ways to do this, right? Yeah, because some of the unknown being on the left-hand side, right?
Yes, sir.
So if you wanted, you could rewrite this as minus 20 plus a is equal to 0. When you've seen it like this, you should be able to find the answer now. So what does not belong on the left-hand side?
The minus 20.
So what I have to do the minus 20.
Move it across and become a plus 20.
Right, so
Up
a
on
would be equal to,
positive 20.
right.
Right.
That's one way you could do it. Or,
You see that? You see how close you is, boy? Magic.
the one is the hype, man. Right? This is another way you could do it, right? A, right now, where's A? A is on the left-hand side or the right-hand side?
Right.
A is on the right-hand side.
Right then.
So we could leave it on your right-hand side and we could just move across the minus 20. If I do that, what am I going to write on the left-hand side?
Minus 20 equal 8.
No. If anytime you move across something, the
Oh, plus 20 equal 8.
right 20 is equal to A, and then I could just switch it around and A would be equal to 20. That's two ways you could do it.
Okay.
Right, so that's the answer. A is equal to 20. Everybody okay with that? Serena, you okay with this?
Yes, so we're good. Because I sent you my answer before.
Oh
Like
no,
a while.
I said Serena.
Oh, okay.
Yeah, but yes, that's correct. Serena, let me know if you're there.
Yes, sir. I'm okay with it, but I was second guessing myself.
Oh, okay, okay. You're sure you're 100% okay with it, right?
Yes, sir.
So you understand that in remainder factor theorem, all you're doing is you're finding for x, you're putting it into the function. If it's a factor, it will be equal to 0. If it's not a factor, it will have a remainder. Understand?
Yes, sir.
So in this question, x was equal to minus 2. And since it said it was a factor, that means f of minus 2 had to be equal to 0. And from that, we could have formed the equation and solve. Great. Right? So Avinash, copy this song real fast. You don't have to copy down this part over here. Then we're going to do a question. Well, then I'm going to give you all a question to do. All right, so Avinash, as soon as you have it copied down, let me know.
Done, sir.
Okay, let's do another question. Not sure where the screen went.
We went in the back rooms, that I do.
Yeah, it went to the back rooms. They're trying to find its way back.
They reach.
All right. So, Sheena, I want you to pick a year. From 2012 to 2024. Pick a year.
2021.
Okay. Pick a nice year.
Um, 2019.
No, I like this year. It's a good one.
Oh, okay. I was still telling him to pick a better one.
No, no, I like this one. Trust me, I like this one. It's a good one. Right. So I don't know what's going on with the screen. What the jail? Like I move on the screen and now I can't see it. Let me try switching the display port. On every cable is giving trouble. All right, are you guys seeing the screen just fine? Let me know if you're all seeing the screen.
Yes, sir.
Okay, cool. So Avinash, be very honest with me. I think you'd be able to figure out this question.
Yes, sir, but I'll need some time.
Okay, so Avinash, so ladies, I'll like start the question, right? I just want to run through it with Avinash. So Avinash, I want you to read the question for me.
Determine the remainder when f of x equals a x cubed plus 7x squared minus 7x minus 3 is divided by x minus 1.
First question, are we going to use polynomial long division?
No?
No. Let's look back at when we use it. We only use it when
Yeah, find all factors.
does this question mention anything about factors?
Nah.
What does it want you to find? Determine the what?
the value
No.
of A. Wait, which one? Oh, determine the remainder. I don't read any
Remain.
second part, so sorry.
They want you to find the remainder. So do you have any idea as to how you would find the remainder?
You know, I, yeah, this substitute the X.
Say that again?
You have to thing for the X.
We mean think X. No.
The X.
Imagine if Avinash, when he opened up paper, he gonna and say think for X.
Nah,
Avinash.
so I like that.
All right. So we have to
So
find for X. So what would X
fine.
be equal to?
The AX cube.
No.
No,
You need
one
to
minus.
you need to put whatever they give you equal to zero.
Okay,
That's the always doing that. So x plus 2 is equal to 0,
0.
x minus a is equal to 0, 2x plus 1 is equal to 0, right? X minus 1 is equal to 0. That's you're always gonna do that. Right? That's
Okay,
right. So what would x be equal to if you put it equal to 0?
0.
No. Hmm.
Oh wait,
If you put x minus 1 is equal to 0, what would x be equal to?
-1.
Nah.
Hmm? Okay, I confused myself here now.
All right. We want to find for x. X should be the only thing on that side. So what am I
Oh,
going to do?
here we positive 1.
Right.
Uh,
Another way to do the question, what would you have to minus from 1 to get 0? What minus 1 is 0?
1 -1.
Yeah, so x is 1.
That's
That's
1. Okay.
an easy way to do it. Right? So x is equal to 1. Where am I going to put that to find the remainder?
To the X,
So wherever I see x, I'm going to write.
1.
Great. So do that for me. So you're going to say f of 1 and you're going to find the remainder. Yeah.
That's a
Right, ladies, how are things progressing? Shayna, is everything going okay?
Oh, yes, sir.
Yeah, okay, nice. Serena, what about you?
Yes, sir.
Start with 1 second.
Okay. Serena, how things going?
Good.
Good? All right, you got through the first part.
Yes, I did.
All right, nice. And the second part, that coming along well?
Yeah, but I'm still doing it.
Okay, no problem. All right, guys, did any of y'all get an answer? Okay, Serena, I saw that you sent me something. All right, Serena, let me know if you're there.
Yes, sir.
All right, so Serena, you get a catch. In the first part, did it say that x minus 1 is a factor?
No.
Nah, they didn't say x minus 1 was a factor. So can you say that f of 1 is equal to 0?
No.
Nah, you can't say that. So the answer supposed to be a minus 3. A minus 3 is the remainder. Let me know if you
Also,
understand.
I'll come back if I finish the first part. And I'm going to answer that question, the second part.
Okay, word. You got you got f of 1 to be equal to a minus 3.
The ministry, yeah.
Nice. So Serena,
I'm going to look it up.
let me know if you understand what I'm saying.
I think so, but could you explain it again?
Talk a little louder, struggling to hear.
I think I understand, but could you explain it one more time?
Okay. So they wanted us to figure out the remainder when f of x is divided by x minus 1. So before I start, I just want to say the remainder factor theorem is the same thing, right? Is the same concept. All you're doing is you're finding for x and you're plugging it in. When you plug it in, you are actually finding for the remainder. If the remainder is 0, it's a factor. If it's not 0, it's not a factor. So you understand that part?
Yes, sir.
Nice. In the first part, did they mention anything about x minus 1 being a factor?
No.
Nah. So if x minus 1 isn't, they didn't say is a factor, all we're going to do is we're going to find what x is and we're going to plug it in. Right? And whatever we get, that will be the remainder. Now, if they said it was a factor, then you would have put 0 is equal to whatever you get here. But since they said it was just, since it didn't specify, I see that it says my internet connection is unstable. Did you hear what I said?
Yeah, I heard what you said.
Okay. So do you understand that in the first part, they never said it was a factor?
Yes, sir.
They never said it was a factor. So all we're going to do is we're going to find for x, x will be equal to 1. And then we're going to plug 1 into f of x. And simply put, whatever we get, that's the remainder. Yeah. So let me know if you're still confused about some parts.
No, I think I understand now.
Okay, and just to make sure you're extra sure, let's look at part B. In part B, what did they say about x plus 2?
They said that it was a factor.
Right. So since they said that, that would have meant that f minus 2 had to be equal to 0. Right? Because when you find for x and you plug it in, that gives you the remainder. And since it said it was a factor, that means that the remainder was 0. So that's why I could say f minus 2 is equal to 0 and solve for a here. But I can't do it for this question because they never told me it was a factor. All right, so work that out back. I mean, you don't really have much to do. All you have to do is just scratch off the 0 and write f of 1 and erase or just scratch off the last two lines. Right? And I believe you made the same mistake for the other part because in the other part you said f of minus 3 is equal to 0.
So that's when looking.
Okay, I'll check it just now, Sheena. Yeah, so Rena, for the second part, you said f of minus 3 is equal to 0. I'm not hearing you if you're talking.
Yeah, I did.
Do you think that's correct or that's wrong?
That would be wrong.
That would be wrong because in part 2, did they say that x plus 3 was a factor of f of x?
No.
Nah, they didn't say that. They didn't say that. So be careful, right? Hi, Emma.
I said,
I teach hard maths. I shift the time now, so I'm gonna finish just now. I just want to finish up this question, and then I'll start with you guys. Just bringing back memories.
take your time, sir. Just let me know when you're ready.
Oh, but we're just bringing back memories. Like what you see on the screen and bringing back memories, bringing back PTSD.
I like this topic.
Okay, that's good. So guys, this is Emma. This is one of my past art math students. She's now doing pure maths. Yeah. So if you have any questions, you could ask her.
Right.
We boy, the real antisocial. Nah, man. She nah.
Hi.
Boy, yeah. If you have any questions, I'll could direct it to Miss Hussein. She's
Yes.
exceptionally good in art maths.
No.
So
Yeah.
this man done dedicating his part to the second teacher already, the same day.
Well, the past students help him out. I will say that they help him out.
Yes, right. So I
Okay.
thought them secured for Emma they in the business.
Yeah, if Emma want to be in the business, say no more. Emma, you come through.
I don't mind teaching CSEC. I don't think I could teach Kate. That's too much work. I don't know how you do it, so.
All right, trust me. Right now, I real struggling. I real struggling with everything, managing everything. I drowning. Yeah. After this, I had to do programming and maths.
Ew.
Right. So, ladies, did you all get through? Serena, will you get through the first part? Are you getting through the second part?
Yes, sir.
Okay. Sheena, let me check your working.
So I realized I sent that to the wrong person, so I now put it back.
Wait. Okay. Uh, yep, that is looking correct. Great. Great. All right. Sheena, I know that'd be a good question to add into that.
What's that?
They could add in since okay, so based on the value of A, is x minus one a factor? That'd be a good question.
No.
You tell me, since you got A to be equal to 3, do you think x minus 1 is a factor?
Yes, sir. Wait. Oh, your first answer was
Or was
A
it?
minus 3.
Yeah, the remainder for the first part was A
Oh,
minus 3. So if A is equal to
it
3,
would be there. Yeah, it would be a factor.
yeah, nice. So I got adding that. It's a nice question.
So I
Okay.
now realize why you asked me. This question was like unlocking brain parts in my head because I was so lost when I did this at first.
But easy now, right?
Yeah, I just watched it and I even remember the equations.
Oh yeah. You have to. Oh, right? So I'm gonna add in a third part based on the value of A. Imagine Shweta coming in thinking that this is pure maths.
I now tell her,
Oh, you
could
know
you
what we
come
should
to this art math class right now? And she's like, okay, I come in.
should not tell she should not tell she.
Sorry. We
It'll be
should have joined
funny.
late anyway, and we would start pure maths without her anyway.
But it'll be funny now if she come in here and was like, what? And imagine if she was like, this looking real hard. And I was like, this is hard maths. And she's like, what? That'll be real funny.
No, she would remember this question.
No, for
I'm
sure. For sure. I just joking. Yes, you I did not remember this one. This one was a interesting one. Because part two. Yeah, I remember doing this paper with you all. So, Serena, you ready to answer the question?
The second part of it?
You get through the second part?
Yeah.
What you get for the second part?
F minus 3 is equal to A minus 3.
Mm, nah.
No. Okay.
Actually, I mean, you're not wrong. You're not wrong. But you need to take what f minus 3 is and do a substitution. So what did you get for f of minus 3?
Could you explain what you mean?
All right, so did you get the remainder for f of minus 3? So when you plugged minus 3 into the function, did you get a remainder?
Yes.
What was the remainder you got?
Um, would it be the minus 27A plus 81?
Yes, that's self, right?
Yeah.
Because and you understand, once you put x, once you put the expression equal to 0 and you find for x, when you take that x value and you plug it in, you actually find out the remainder. So in part 2, they're saying that the remainder, when f of x is divided by x plus 3, is equal to the previous remainder. So if that is the case, Serena, then you'd put the two remainders equal to each other and then solve for a. Right? So let's answer the question on the screen quickly. So let's answer part 1 first. Right? So Serena, explain to me, how would I work out part 1?
Okay, so first you would equate x minus 1 equal to 0, and then you would determine the value of x, which would be 1.
Right?
You would substitute x into the fx function, and so you get a open brackets 1 close brackets to the power 3 plus 7 open brackets 1 to the power 2 minus 7 open brackets 1 minus 3.
Right? And am I going to put that equal to 0?
No.
No, if I put this equal to 0, I'm saying that f of 1 is a factor, right? But is x minus 1 a factor? Did they say that?
No, they didn't say it.
Nah, they didn't say that, so we can't assume.
Mm.
So what we have here is the remainder. What we're finding for is the remainder. So whatever we get here, that will be the remainder. So 1 cubed is 1, so a by 1 is 8. 7 by 1 squared, 7 by 1 is just 7, right? Minus 7 by 1 is minus 7 minus 3. So what will we end up with?
A minus 3.
Right. And you understand that that will be the remainder, right?
Yes.
Right. Nice. I want you to read part 2 for me and carefully soak it in.
Okay. If the remainder when f of x is divided by x plus 3 is equal to the remainder determined in a part 1, find the value of a.
All right. So, Serena, in part 2, they're saying that there's another remainder, right? And this time, they are talking about the remainder when we have f of x and we divide it by x plus 3. So how would I find that particular remainder? How would I find that?
You would use the remainder factor theorem, like what you did in part 1, but use it on x plus 3 instead.
Yep. So let's say f minus 3, that would be a minus 3 cubed plus 7 by minus 3 squared minus 7 by minus 3 minus 3. Just confirm that correct. That's what you have?
Yes.
Okay, would. Are we going to put 0 here?
No.
No, because at no point in time did they say that x plus 3 was a factor. They never say that. They never say that. Right? So minus 3 cubed, that's minus 27. So minus 27a. Minus 3 squared is 9. 9 by 7 is 63. Minus 7 or minus 3 is plus 21. Minus 3. So 63 plus 21, that would be 84. 84 minus 3 is 81. That's what you got?
Yeah.
All right. Okay, next thing. What we just found for here, that's the
That's the remainder.
right. Just write remainder a little better. Okay, cool. All right. So we have two remainders here. Now, Serena, what are they saying about the two remainders?
They say that the remainders are equal to each other.
Right. So if the remainders are equal to each other, then I could say a minus 3 is equal to
Minus 27, a plus 81.
what do I want to find for?
Um, a?
Yes, a is the only unknown here. So I want all the a terms on the left-hand side and all the numbers on the right-hand side. So what shouldn't be on the left-hand side here? What shouldn't be there?
The negative 3.
Right. So we had to move our negative 3 across. What shouldn't be here?
The minus 27a.
Right? Move that across. So tell me what you write in the next line.
A plus 27a equals to 81 plus 3.
What is 1a plus 27a?
28a.
And what is 81 plus 3?
84.
So I have 28 a's. How am I going to find for 1?
Divide both sides by 28.
Nice. And I think that should be 3.
Yeah.
All right. So we have successfully answered part 1 and part 2. What do you think about it? Easy, hard, manageable?
Manageable.
You wouldn't go so far to say it was easy.
No, because I was kind of confused by the wording.
Ah, but you understand it now, right?
Yes, I do.
All right, let's add in another part. Part 3 says, based on the value of a is x plus 1 and x plus 3 factors of f of x. Let me see if you could figure this one out. Right, so based on the value of a is x plus 1 and x plus 3 a factor of f of x? What do you think?
Yes. I'm not
No.
sure. I'm not sure.
All right, you said yes.
Yeah, but I'm not sure about my answer.
All right. If something is a factor, what do we know about its remainder?
Its remainder would be 0,
Right. What do we find a to be?
3,
What was the remainder when we divided f of x by x plus 1?
a minus 3,
Right. If we found a to be 3, what would the remainder be for the first part?
3.
Nah.
No,
Check it out, right? The remainder here, we got a minus 3, right?
it would be 0.
It'll be 0. So
Yeah.
is x plus 1 a factor?
Yes.
Yep. Right? If we put 3 into this, what's minus 27 by 3? Say that again?
Negative 81,
What is negative 81 plus 81?
0.
Right? So in other words, the actual remainder is 0. So question, is x plus 1 and x plus 3 factors of f of x?
Yes.
Yes. You say that like you're unsure.
Because the first time I said yes, you told me no.
Oh, remember, I really struggling to hear you talk.
Okay.
Like it's really, really hard to hear. Could anybody else vouch for me? Like, are you all hearing Serena? Or like barely?
Really?
Barely, yeah, like it's real hard to hear.
I don't know if you like Haship on a separate call or like I barely hearing anything.
Yeah, like I have my ears up to the speaker right now.
She's bird boy.
Yeah.
And the way how it song is so I thinking like yeah, Haship on a separate call.
No, no, no.
Like real talk.
I just have my ears up to the mic. I mean up to the speakers. Yeah.
At that time, you see the lens this man go for y'all?
Oh, yeah, you're bigging him up too much. All right. So, Serena, let me know if you're 100% confident in it now.
Yes,
All right, so let me just finalize this. So we're going to say x plus 1 is a factor because f of minus 1 is equal to a minus 3, which is equal to 3 minus 3, which is equal to 0, right? And x plus 3 is a factor because why, Serena? Serena?
yeah, because f of negative 3 is equal to negative 27a plus 81, which is equal to negative 81 plus 81,
Perfect.
which is 0.
Right? And I suppose I could add in one more question. What is f of x equal to? What is f of x? Do you think you could tell me?
Is it 0?
Nah.
No? Okay.
Let me just add in that. Serena, you have it, you know. You have it. You could figure this out. I'm sure.
Woo, 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 woo.
Right, sir? What is f of x? Right. So, Serena, the question is, what is f of x?
Or would it be ax cubed plus 7x squared minus 7x minus 3?
You're halfway there.
Hmm. Oh, 3x squared, 3x cubed minus.
Yes. Yes. Right. So part 4 would just simply be, you're just gonna plug in where you found A to B. That's it. Right? So f of x. Great. So Serena, I feel like you understand factor remainder theorem really well.
Yeah.
Yeah. Okay. Good. Right. Shayna, yeah, you feeling 100% like this real easy? What do you think? I not realize Shayna not here. Shayna Wi-Fi is a real play up. Okay. Right. Avinash. Haven't seen the solution. Is it bad or like is manageable?
Manageable. As I practice more with it.
All right. So I will send homework. Avinash, pick a year.
Uh, 2002.
No, no. Admat starts in
Huh?
2012.
What?
This
Yeah.
man, this did Avinash really good, you know. He gone 1 year before I born. 1 year before I born. Avinash, that's a real skill boy. One
What?
year before I born.
What? I'm not working in timeline, boy.
Yeah.
Wait,
So
nah.
Avinash.
Huh?
So you
Ah,
could
you
pull
can't-
up a
you can't do
GCSE
so.
paper, if you want 2002.
I suppose I could
Yeah.
do that. I could get a G.
Oh, my God.
Ah, joking.
But pick a
I'm
year.
just saying, I'm 22, so my bad.
2000 and,
22.
2022.
Oh, God. But you know what? That one actually, that was really good, boy.
Yeah.
Now, before I see light.
Because Stefan, you're younger than me.
Yeah, but that's before I see light, boy,
Yeah.
2022. 2002. Yeah, like saying, boy.
All right. So yeah, that's all your homework. So guys, thanks for coming to class today. Right? Before I leave, if I want to ask Emma and Shweta any questions concerning add maths and pure maths and thing, or I could ask them. If not, bye everybody. I'll see.
Ask them how they find it. If they've been struggling first.
Hmm. Well, Serena she like maths and add maths. Shweta and Emma. Serena is like a real scholar.
Good job, you're gonna do well. You'll get your ones.
Yeah.
This man, scholars, like.
Serena gonna get distinction. Sheena and Serena, like them real. Look, Sheena now coming back in the meeting. Oh, Sheena Wi-Fi is something else, yes.
Come back when the meeting done.
Yeah. Mm. Sheena, hi. Hello, Sheena. Look, Sheena, come back. I'm not sure if she's hearing us. Okay, I take that as a no. Um, right. Well, we're ready to start pure maths. Right? We're ready to start pure maths. So yeah, everybody here that did add maths, or they could leave, unless all they want to see pure maths. But yeah, guys, thanks for coming to class. I will see you all. I'll see someone there tomorrow for physics. Right? Later, add maths people.
Bye, sir.
Bye bye.
Later.
Right. Look, Shayna's still in class. I'm so confused.
Yeah, clean here anyway.
I don't know. All right. I'm gonna stop this recording.